Hello and good evening, everyone. This is Ankit. I'll be your trainer for the day. Let's give a couple of minutes for everyone to join and then we will start with our session. Meanwhile, people who have already joined, please open the OOPS notebook. We will continue with OOPS today. Please execute the latest available class employee.
Yeah, hi Ankit, I joined the call.
All right. So please open your Jupyter notebook for OOPS. We will continue with OOPS. Let's open the Jupyter notebook and execute the class employee, the latest class employee that we would have done. Let's open that. Done. Oh, let me share my screen. And this is the latest code. Yes. Okay. Let me zoom in slightly. Okay. So what we are going to do is we are going to write down a couple of more functions in this class employee. Today's target would be to complete inheritance. And if time permits, we will also try and complete polymorphism today itself. All right. Now, so a quick revision on class. What we are going to do is we are going to define our custom classes. A custom class is nothing but it's a blueprint or an architecture and it consists of different functions and your constructor function. Your constructor function is nothing but it is used to define and assign values to your data members. In Python, the default constructor function is init. The left-hand side that you see here in the init function are called as the data members. The right-hand side of the assignment operator are the values, which will be thrown from object creation or the instantiation of the class. Now there's a word called as self, which is used to store the current instance so that Python knows that for which object are you trying to assign the values. In case of functions also, you will have to always assign the self. This means this is a non-parameterized function. It does not take as input anything. But Python, while sending out, will send at least the current instance of your class. Now, last time, I hope we have discussed that these are the data members that as an architect of the class, you will always try to keep it hidden. Sorry for that. So yes, so the data members of a class, you will try to keep them hidden. You will not disclose your data members so that the users of your class are not able to directly update the data member values. So what do? You tell the other developers that this is the class employee, and if they want to see any specific information, you will write down a function called as get, which will return the corresponding values. So we created one employee object for which if we want to look at the salary or the full name, we have created certain functions which will return the salary and the full names. Now, after that, what we can do is I'm going to write down a couple of new functions. And the new function I'm going to say update salary. Now, this is a function that you have written because the HR came to you and the HR said that, hey, I want to update the salary of a particular person. I want to increase their salary by a particular amount. You say, okay, do one thing. You will have to pass the amount with which you want to increment the salary. You will have to tell me, let's say if you want to increment the salary by 5,000 rupees, you will have to send me those 5,000 rupees. I will update the current salary and update it by 5,000 rupees. So what are you asking them? You're asking them to send something which is called as the increment amount. And what you will do is you will say, okay, self dot salary. You will assign it, you will say self dot salary plus increment. Okay. Now, what are you going to do here? What do we do? You see that you have created a function to update the salary of a particular employee. So you say for whichever object or whichever employee object you are planning to call this update salary function, you simply pass the amount or the increment amount that you want to be added into the employee salary. For that particular employee, what I will do is, see, this is again an assignment operator. This is again an assignment operation. So you see that the right hand side of the assignment operator will be executed. First, you are saying that take the salary of the current object, whatever current object this function has been called. Take the salary, add increment amount to the current salary, and then reassign this new value to the data member salary. So now what I'm going to do is I'm going to execute this. I say employee one dot get salary. If you see the employee one dot get salary currently has thrown 5,000. So let me do update underscore salary. So the moment I do this, and I'm going to pass, let's say 2,000 rupees. So the moment I do this, let's see what is going to happen. After this, I'm going to execute. See, it will not give you any output. The reason is because it will simply update the data member. If I check the salary, if I again say get me the salary of this employee, you will see that it has been increased from 5,000 rupees to 7,000 rupees. Because what happened? The moment you call this function update salary, Python went inside. It went inside, looked for the update salary function in the employee class. In self, the EMP1 object reference goes and sit in self. Increment is the amount that you have passed through here, which is 2,000 rupees. So self dot salary. So EMP1 dot salary, which was 5,000 plus 2,000, total becomes 7,000. And this 7,000 is then assigned back to a new data member, or let's say to the existing data member, which was called as self dot salary. So in this way, you can update the values of your salary. You can update any of the data members. You can actually set any value to the data members. So what did we learn class? That if there are data members, if someone wants to view the values of a data members, we can write down some functions and return these values. If someone wants to update or modify the values of your data members, you can again write down a function and expose that function to other users which they can use. So with this, what did you do? You have controlled how the value increment is happening for your data member. No one can directly update. They will have to pass the amount. You say you will have to pass the amount. The amount when it comes to the function will be used to modify the current salary of the data member object. Class, do not forget to re-execute the class. Every time you make a change in your class, re-execute the class code so that it gets registered in the Python memory. Also, you will have to re-execute your object creation code so that the changes are bound back to your object. Otherwise, the old class will be bound here. You'll always have to re-execute the object creation code so that the new values are bound back. Let me know once done. Let me know in case of any issues or errors as well. All right, I'm going to make an assumption that we are done. If not, let me know in the chat and I'll give you one more minute. And I will give you. All right. So with that, let me open a new whiteboard. Let's go. There are certain pillars of OOPS. See, till now, what we have seen classes, how to create a class, what is the constructor function, what is self. You can have a collection of functions and data members. What are data members? What are functions? How are the objects created? How you instantiate an object? How can you assign values to a data member? How should you return these data members? How should you modify these data members? So, see, if you paid attention, I said, how should you? There are multiple ways, and these are generally considered to be the way that we are looking at, generally considered to be the best ways of achieving what we're trying to achieve. Now, after this, what I want you to take through is called as the pillars of OOPS. There are certain pillars of OOPS, there are certain concepts that we are going to go through today. These are called as the pillars of OOPS. There are 4 pillars of OOPS, and we'll try and cover as many as possible in today's session. Let the whiteboard load. Let the whiteboard load. It's loading very slowly. Okay, so for the time being, I have removed the chat. Let me know if you have any question. Please put it in the chat. But I want everyone to please pay attention to the screen. See. Now, we have something called as the pillars of OOPS. Now, there are 4 pillars of OOPS. The first one, we are going to look one by one at each and every pillar. I'm going to first begin with something called as inheritance. Okay. Now, inheritance is a term which is also used a lot legally. It's an English term, and whatever meaning inheritance has, Python has implemented the exact same meaning in OOPS. So the first pillar of our OOPS is going to be inheritance, and we are going to see how this inheritance works. Okay, so let me give you one very simple example, class. Let me give you one very simple example. And the example is, let's say, let's forget about programming. Let's look at some real life example. Let's say there is a parent. Okay, I'm going to say this is a parent. Parent has characteristics C1 and C2. The parent has 2 child. Or sorry, the parent has 2 children. Child 1 and then we have child 2. See, if the parent has 2 children, child 1 and child 2, child 1 will have the default characteristics which are already present in the parent. So by default, it's always assumed that the children will always have whatever characteristics their parents have, and then they can have their own characteristics as well. Okay. Similarly, the other child will obviously have C1 and C2, which are the characteristics of the parent, and it can have its own characteristic. Now, it can have its own characteristic, which will definitely be different from child 1. So what do we see? If you see here, what has happened is your C1 and C2, these characteristics are present in both your children. That means, can I say that your child can access parent characteristics? Yes, I can say. This means C1 and C2, which are present in my parent, are available for the children. By default, they can directly go and use them. It will automatically become available to your child. Right? Now let's replace all these characteristics with technical terms. Let's call them data members and functions. Okay. Now what happens is we have a parent class, right? In Python, as a part of OOPS, a child class can always inherit a parent class. It can say that I am going to inherit the parent class. In that case, what happens is the data members and functions which are present inside your parent become available and accessible to your child class. Let me say once again, as we discussed about the different characteristics which are present in parent become automatically available to the child. Similarly, the concept of inheritance in Python says that what if a child, so this is a class, this is some other class, and I'm going to say that my child class is inheriting from my parent class, which means that the data members and functions of your parent class will automatically become available to your child class. The child class will be able to access the data members and functions of your parent class. It's as simple as this. See, if we all have, so let's say, if a parent has a child, right, we can go to our parents' house. The house that our parents have is accessible to us whenever we want. If we want to go to that house, we can always use that house. That's what the general inheritance term means. Similarly here, in this case, if there is a parent and the parent class will have certain data members and functions. And if a child class inherits the parent class, it means that the child class can easily access data members and functions as and when required of the parent class. Now, having said that, let's look with the help of a couple of examples what is happening here. So I already have a class called as employee. Now let's go back to our system where we were designing and developing a system to create and update the employee information. The HR comes to you and says, see, what the system that you have created is good, but now there's a problem. We are planning to expand and we are taking a lot of interviews. So now I want you to help me create and update some person information. It can be any person. They may or may not be an employee. That's okay. Whenever a candidate applies, I want to create a new person and update its values as and when required. So you say, cool, that should not be a problem for me. You tell me what all information do you need about the person, or what do you want to do with these people. You say, cool. See, what I want to do is I want to have certain characteristics, and the characteristics that I want to have, it can be I want to create an ID. I want you to take care of the first name. It should have your second name. It should have certain salary expectations. What are the salary expectations? Then we should have the date of birth. We should have gender. Okay. We need address. We need something called as the address. And let's say finally we would need some government ID number. Let me say let's have some UID, which is the unique ID of that person. Unique ID in case of India is Aadhaar card. In case of United States, do we know most of the clients are from United States? Do we know what is the UID in United States? Anyone? Anyone knows what's the unique ID? Have you heard about social security number? So how we have Aadhaar
Yeah,
card? How we
yeah, the PAN, those are UID, like unique identity cards, which cannot be shared, I mean,
that's
duplicated or given to someone.
that's it. So Aadhaar PAN card in case of India,
Like
social security
our
number
employee,
in case of the United States. So these are not the employee IDs. Generally, any government provided ID. In India, UID today is considered to be the Aadhaar card number. In United States, it's going to be the social security number, the SSN number. So you see, now this is good. You see, this is nice. You say, okay, I have enough information. I can create the class required. But do you observe one thing? Do you observe that there are 4 things for which you already have a class? For these 4, you see that these are the 4 parameters which are already present in a class called as employee. So you say, cool, then why do I need to define new data members if my employee class already has these 4 data members? So what you're going to say, let me inherit from employee class let the parent class. So what will happen is you will create a new class called as person. This person is going to inherit from the employee class. You are going to worry about 4 new characteristics or 4 new data members, and let your parent class worry about your existing 4 data members. How? Let's see. So let's go back to our code. Before I go back to the code, let me quickly revise what we're trying to do. You have a new requirement wherein you have to create a class called as person. This person has 8 data members as per the discussion with your HR, and you observe that 4 of these data members are already existing in a class that you have created. So you see that this is the opportunity. So whenever you have cases like this, that you have your data members, you have your functions which are already present in a particular class, right? You can have data members, you can have functions which are already present in some other class. In that case, you know that, okay, I can inherit that class and directly reuse it. So the idea of inheritance is reusability class, okay? You want to reuse an existing class. When you have some functionality already written to take care of certain data members or certain attributes, why do you need to again and again rewrite the same logic? If I create a new person class without any inheritance, what will I do? I will create this 8 data members in an init constructor. I can use different same functions. See, to get the name, I will have to write down a get name function. To update the salary or get the salary, I'll have to write down the same function. But these functions you have already written in employee. So why do I need to write more? I can simply reuse it. So reusability is one of the reasons which makes inheritance very, very famous among Python developers. Reusability. Okay, this is the most famous. You don't have to worry, you can simply reuse. And how do we do that? Let's go back to our screen and let's see. Let me go to our notebook. And what I'm going to do is, what I'm going to do is I'm going to write down a new class. And for that, let me bring back the definition for your reference back here. I'm going to bring back the definition here. And I'm going to start with a new class for the concept of inheritance. I will say class person. You already know that this class person is going to inherit the class employee. So if you see this class employee that we had previously defined, it was not inheriting anything. So we could directly go with colon and start writing the class definition. In this case, as we want the person class to inherit employee class, we will enclose the parent class name in the parentheses, which are immediately followed by your child class. So this syntax indicates that you are creating a new class person, which is inheriting the employee class. The moment I say this, it means that all these 4 functions will be available to my child class object. They would be directly available to my child class object. You need not redefine them. You need not use them. 4 data members which are already present, you are happy. You can directly use these 4 data members. You don't have to write down any logic to assign values to the existing data members. Let's see what I'm going to do. As the class starts, I'll first begin with my constructor function. And it takes 8 parameters, right? So we know that the object person that we are going to create requires 8 parameters. So I'm going to say EID. So let's begin with self. Self, I'm going to create EID, fname, name. Then I have sal. Then I have some more properties which are DOB, gender, then I think address, and then finally UID. Now, you know that in order to create this person object, you need 8 data members. That means the constructor function will require 8 values. But we are going to use inheritance. We have clearly defined that my person class is inheriting my employee class. So what I can do is I can, inside the function definition, I'm going to simply call my parent class init function and use it to assign values to my parent class objects. So I'm going to simply say that fname, sname, and salary. These 4 values let the parent class constructor take care of. See, to create or to construct a person class object, you are asking the user to send you 8 values. You're saying that a person class object has 8 data members. Okay, it has 8 data members. Anyone who wants to create a person object when they're trying to create an object of type person, they will have to pass 8 values. Like how here we had passed 4 values, they will have to pass 8 values. You want to create a person type object, you need to tell me what is the ID, first name, second name, salary, date of birth, gender, address, UID. But what we are going to do, we have used inheritance, meaning that the person class is inheriting employee class, indicating that this constructor, this is a function which is already present in your parent class. This is available to you. So why don't we use it? You say, okay, for the first 4 values, I already have a function which is written here. So what I'm going to do is I'm going to call this function and pass those 4 values to the parent class constructor. So inside your child class constructor, you have called the parent class constructor. For rest of the values, you will say, okay, for rest of the person, let me say person underscore DOB is equals to DOB self dot person underscore, what do we have? Gender. GEN is equals to gender, then self dot PR underscore ADDR is the address value that you want to assign it. And finally, self dot person underscore UID will be UID value that you have assigned. Now, do you see how short this code has become? What we have done, class, what we have done, see, let me tell you what we have done. Instead of saying these 4 lines, right? These 4 lines, I already have these 4 lines. Ideal case scenario, let's say if there was no employee class. Okay, let's say there was no employee class. This is what your class would have looked like. Do you all agree that if, let's say, there was no employee class in existence, there was no employee class which is available, what will you do? You will see that you are going to write down these 4 lines, right? Now, if since you're planning to use these 4 lines, instead of writing these 4 lines, you see that these are already existing in some class? You see, okay, I have a function where exactly I have the same 4 lines, exact same 4 lines, right? I have a data member called as ID, first name, second name, salary. These are the data members for which I already have a function which is present. This is where you recognize that, okay, what I can do is I can inherit my employee class, and instead of using these 4 lines, reassigning the values, what I can do is I can use my parent class constructor and remove the other lines which are not required. So you have reused the code. See, in very clean manner, you were able to access the parent class constructor to define certain values which are already existing. For the new characteristics or for the new attributes, you have defined your code. So the characteristics or the attributes, rather the data members which are coming from your parent class, to assign values to these values, you have used your parent class constructor to assign values to the new data members that you have. What you have is you have written down your own code. And after this, you can simply execute the code and register it inside the memory. Now let's see what I'm going to do. I'm going to create a person. You know that I need 8 members. So I'm going to say 103. Let's say the first name is Nana, or let me use a new word. Let's say the first name is Jane, followed by Doe. Then we have salary, which I'm going to say, let's say 12,500. Then I'm going to say the DOB is, let's say 12th January 2000 and 2000, let's say. Then we have gender, which says female. And I have address, which says, let's say Bangalore, and finally UID, which I'm going to give a random number. Okay. Now, what will happen the moment I execute this code? So, person, I'm trying to create a person. The user of this class already knows that you have to pass 8 data members. You have to pass 8 values to this particular class so that you can create an object. How do they know? Because you have defined this inside your constructor. A person has 8 attributes. 4 are the attributes or 4 data members you have defined here. The other 4 data members are coming from your parent class. These will be shared. This will be easily available to your person class. So the moment I do this, what will happen? 103 will go and sit in. Okay. So first, let's look at self. The moment I execute this code, Python will go and start looking for the constructor function. It will go and start looking for a function with the name underscore, double underscore in a double underscore. The moment it finds this function inside the person class, it will start assigning values to the parameters here. Inside self, it will send the current instance. In this case, it will be per1. 103 will go and sit in EID. Jane will go and sit in Fname. Doe will go and sit in Sname, and so on. These values till 1, 2, 3, 4, 5 will go and sit in UID. You come inside the function and you see that the first call that you have done, this call is called as the parent class constructor. You have called the parent class constructor. Now, what do you do after this? After this, what you do is these four values. See, now we are done. EID stores the value 103. You know what these four values are. You take these four values and pass it to your parent class constructor. What will your parent class constructor do? It will take self still has per1. You see, per1 was passed from here to here. From here, it has been passed to this particular function call. Self has PER1 here. And when it goes and sit here, here you have PER1, 103, Jane, Doe, and 12,500. So now it says per1 dot EMPID is equals to 103. Let me execute. Let's see what I just executed. Is it true? Per1 dot EMP underscore ID is equals to 103. Okay, let me see if this returns 103. And here. So do you see that all the attributes, all the data members which are present in your class employee will be available to you in the child class? You can check any of these four data members. They have been shared because of the concept of inheritance, and the person object will also have its own attribute. Let me see person.address, which has been defined here. So you have defined four data members here, and four of the data members are coming from your parent. This is how you can reuse the code. You can also see that if I check the parent class function call, let me say parent class function. So what I'm going to do is let me put a comment here. You have called parent class data member, which worked. Right? This is its own characteristic. I'm now going to call the parent class function. It does not have any function apart from the constructor. So let me say PER1 dot get salary. Okay, the moment I execute this, if you see PER1 goes inside here, the object, and it sees that there's just one function in it. So do you think it will run an error? No. Why? Because person has inherited employee class. That means all these functions are available to the person class object. And you see we have a function called as get salary, which is by default available to the class person. The moment you execute this, what will happen is Python will go first to employee. It sees, okay, you're calling this from employee function. Self will store the value per1 dot salary, and that will return 12,500 rupees. This is how the concept of inheritance works. Let me give you 2 or 3 minutes. Let's quickly make a note of this. Try this out, class. Let's quickly try this out. Let me zoom out a little bit so that you can see the entire code. Let me know, class, if you have any questions. Also, let me know once you are done. All right. So, see, I'll give one more minute for anyone who is still doing this, and then we will move on to different types of inheritance. All right. So, class, now this is a concept of inheritance that we have seen. Let me go back to the whiteboard. Let me go back to the whiteboard. All right. Now, see, class, what happens is uh, what we have seen is, first let me tell you that your parent class, a lot of times and in a lot of books tutorials, see, every time I teach you, what I also focus on is whether your it should be consistent with what we have in most of the tutorials and what we have in most of our books. So your parent class, a lot of books also refer to as super class. Both mean one and the same. And your child class, a lot of books and a lot of authors out there also refer to as a subclass. So I can interchangeably, I'm going to call parent or superclass. So understand parent and super mean one and the same thing. Child and sub means one and the same thing. Now, a lot of call the parent and superclass as the base class as well. There are different terminologies, all mean the same thing. That if you inherit any class, that class becomes your parent, super, or base class, and the class which is inheriting becomes your subclass. Now, in this case, if you see, what we did was called as a simple inheritance, right? What we did was called as a simple inheritance. Why? Because in case of a simple inheritance, what happens is you have one parent class, and from this one parent class, what you do is you inherit a single child class. Simple. 1:1, right? This is your simple inheritance. One parent, one child. Now, in other cases, what we have is also called as a multi-level inheritance. Let me use the entire whiteboard for this. Your multi-level inheritance looks something like this. Your multi-level inheritance looks something like this. You will have one parent, and from one parent, what you have is a child class. Let me call it as child class. And your child, from your child class, you have another inheritance which is happening. Let me say child 2. Okay, so what do you see? This is multi-level. What did we see in our base or in a simple inheritance? You have one parent and one child. But in this case of multi-level inheritance, what happens is you have one parent from which actually, let's say a child class inherits from the parent class, and there is another child 2 class which inherits from your parent class. So if this is an example of, let's say, employee, which this was parent class was employee, and then you had a person class, which became a child class. Now what happens is, let's say our parent class is the employee class. Where is it gone? Yes. Our parent class is the employee class. Okay, so you will say employee here. Your person class is inheriting the employee class, so it becomes your child class. And let's say you create another class called as candidate. And that candidate is going to inherit, let's say, your person class. In that case, what do you see? You have created your person class is inheriting the employee class, and your candidate class is inheriting your person class. So what you have is a multi-level inheritance. Indirectly here, all the properties which are present in your employee will also be present in your candidate class. So you have inheritance which is spreading over multiple levels. Then, apart from this, what we have is a third type of inheritance, which is called as multiple inheritance. Let me write it down here for you. Multiple inheritance means that when you are planning to inherit from multiple classes. A single child class, when it inherits from multiple class, we call it as a multiple inheritance. So let me put it here. Let's say I have one parent class. I have one parent class. So this is the example of multiple inheritance. I have one parent class. Let me call it as parent 1. And then I have parent 2. And let's say both, and I have one child class which can inherit from both parent and child, parent 1 and parent 2. Such a class is, or such a concept of inheritance is called as your multiple inheritance. Why? Because see, in this case, what will happen? You will inherit from parent 1, you will also inherit from parent 2. So let's say this was employee, this was some other class. Let me call the class as apart from employee, what else can you have? Because person is going to be this. Then let's say this is a class which has just the employee personal data. Personal data is already added. So let me say this is your leave data for each and every employee. Now, if you create a class person and you inherit employee and the leave data both, you call this as a multiple inheritance. And then finally, what you have is called as hierarchical inheritance, in which we have already seen you can have multiple multiple. Okay, let me write it down here for your case. We have hierarchical class, not clusterings. Excuse me for that. We have hierarchical inheritance. In this case, what will happen is you will have one parent, and what you can have is two child one and child two. Such a concept is called as hierarchical inheritance. Now, why have I given you the examples of C? The concept of inheritance is going to be same. What will happen is the immediate, whatever parents you have, you might have more than one parent, you might have multi-level, you might have different two or more parents at the same time on the same level. In any case, whatever is available in your parent class will also be available in your child class. We just saw the entire example of how these things will matter. So let me So you will see that all these are the examples of different levels of inheritance. The only concept is that you will see multiple inheritances are available, multiple parents, multiple children, anything is possible. But the only concept here that you need to understand is if you are inheriting from a parent class, one or more, does not matter. It means that the child class will have access to all the data members and the functions of your parent class. If you have more than one parent class like this at the same level, you will have the access of both these parent classes data members and functions. If you have it at different levels like this, then you will have access, still have access of both the parents at different levels. If you have one parent, then both these child classes will have access to their parent class data members and functions. All right. So, all right. If you want to make a note, I'll give you 1 minute if someone wants to make a note of this. All right, class. So with that, we complete the concept of inheritance. With that, we complete the concept of inheritance. If you want, I can quickly showcase you multiple inheritances. There are multiple examples that I can actually create. Let me see if required, we can do that. But however, I would want every one of you to try out different examples of inheritance. Let me see if we have. What we have done here is called as simple inheritance. Let me write it down here. What I'm going to do is I'm now going to give you an example of, let's say, multi-level inheritance. I'm going to create some dummy classes. And let me say that I have class, let me call the class name itself as parent. I have a class whose name is parent. Within parent, I will have one constructor function. I'm going to say this function will accept as input nothing. What I'm going to do is I'm going to simply use and say that I'm going to create self.name as it to let me create a static data member. So every time this class is going to create a person and a data member, John, let me create another class, let's say child, and I'm going to say that this child class is going to inherit from my parent class. Now, there is a good chance that you might have a doubt saying that what is this happening, right? The constructor function in this case, what it is doing is, the constructor function in this case, what it is doing class, it is not accepting any parameters. Whenever you create an object, it will always create an object with the name John. That's it. We are doing this just for theoretical purpose. This has no use case in the real world. In real world, you will always create the object by accepting parameters from the person who's creating the object. But here, just to study, what we are going to do is I'm going to initialize the, or let's say this is what is called as hard coding. Every time a parent object is created, I'm going to create a person with an object name. Oh, sorry, I'm going to create an object parent with the name John. Now child is going to inherit parent. And I'm going to write down a constructor function here, which let's say in this, what I'm going to do is again, see, I'm not going to write down any, I'm not going to take any parameters as input, but what I'm going to do first, I'm going to call the parent class constructor, and I'm going to say, let's use the parent class constructor, and I'm going to simply assign it a parameter called as name. And then I'm going to say the child class, let it simply assign the age 40. So what this child class is doing, it's inheriting parent. That means the parent class constructor is which is available to my child class. I'm going to use it to assign it a data member named John, and the child class just has one new data member called as age 40. So basically what I've done is the name data member which is coming from the parent class is available to the child class, and you can see that the child class has its own characteristic or own data member called as age. Now, what I'm going to do, I'm going to create one more class. Let me call this class as class child2. This class is going to inherit its immediate parent, which I'm going to create as child. So you see a multi-level hierarchy has been created. Parent is a parent to child, and child is a parent to child2 as well. So let me quickly do one thing. Now comes the interesting part, right? A lot of you might ask, what can I access multiple parents or not? Yes, you can. What you need to do is, first let me do this self. Then I'm going to say, let's say child dot init. See, the moment I write child dot init, you have made it accessible to both your parent class constructor, because your child class constructor will first call the parent class constructor. So you don't have to worry about anything. This line in itself, it will do what class? It will assign the name and age both. Why name and age both? Because the moment I call my parent class constructor, this parent class constructor will go and call its parent class constructor, in which you have assigned the data member name a value of John. So the moment you call this in your grand, let me call this as grandchild. Let me call this as grandchild. Okay, the moment you call your grandchild, whenever you create the object of your grandchild, the default constructor will be invoked, within which you have called the immediate parent, within which you have called the immediate parent, for which for the grandchild becomes the grandparent. And I'm going to assign it some new value, and I'm going to say, let's say self.profession, and it's going to be, let's say, developer, or let me say data scientist. Okay, and let me write one more function just for the sake of fun. I'm going to say display details. And what will happen is self dot, or I'm going to say simply say return self dot name comma self dot age, and I'm going to say self dot prof. So do you see class? See, this is a very good example wherein you can clearly see that whenever you're calling this function has access to the data members which are available in its parent class. the immediate parent class has a data member called as A. Rather, let me start in the exact hierarchy. You see, its own data member is the profession, its immediate parent's data member is age, and its grandparent's data member is name. See, age is something which was defined in your immediate parent, and the name data member was defined in the grandparent. All three of these will be accessible inside this class grandchild because it's inheriting child, and child in turn is inheriting parent. So all the data members and functions of class child and class parent will be available in grandchild. So the moment I execute this, and let me create an object, let me say GC is equals to grand underscore child. The moment I do this, if I say GC dot display details, you will see that John, 40, and data scientist, all three have been returned. So what happened here? What happened is the moment I created this object, Python first went and started looking for the default constructor of this object, which is of this class, which is init. Inside init, you have called the parent class. Inside the parent class constructor, you have called the grandparent class. So the first code that was executed is this: self.name is equal to John. So you created an object of the grandchild, but the first data member that got assigned a value was self.name. Then what happens is you have self.age, which is present in your immediate class, because after the parent class code got executed, the flow of control came here, you executed code, the flow of control then will come here, and you will assign all data members certain values. Okay, so this is a classic example of multi-level inheritance. I'll give you 5 minutes. You can clearly make a note of it and try it out. Let me know if you have any questions, if you have any doubts, if you face any error in the code, let me know that as well. Now, class, what I'll do is I'll let you explore the other two types of inheritance, right? The hierarchy and hierarchical and simple we have done, multi-level we have done. Multiple and hierarchical, I'll let you explore it in your free time. Take your entire week. It's good to practice as well. Okay. All right. So class, with that, what I'm going to do is with that, see now we have 20 minutes left in this session. What I need is a stretch of almost 1 hour. So I'm going to check with your admin if I can get a 3-hour session with you. I hope you are okay. I need a 3-hour session because what I want to do is I want to take polymorphism and abstraction and there's one more which is called an encapsulation, all three in a single go, right? If I start right now and stop in between, it might actually cause an issue. Let me check with your admin if that is possible. If that is possible, I'll set up a longer session for you people. All right, and then we might be able to do. Let me know if you are available over the weekends from 10 to 1. The coming Saturday, Sunday, if you will be available from 10 to 1 is something which I'm going to check with your admin. If you are available, we can go ahead and do that lecture. But I think for today, I'll have to wrap up early because if I start, we won't be able to complete a topic. All right, I see one of you is available. So on 17th and 18th, I'll check with everyone. We'll need larger sessions so that we can wrap up topics in one go, because we have certain topics which will require larger stretch. I cannot start a topic now and stop in between. We will have to revise the same in the next session as well. So with that, let me end today's session. We can continue with the session on today is Saturday. Let me continue to Saturday. On Tuesday, we will have the same session at the same time. We will have one session on Thursday as well. Let me check on 17th and 18th. Let's keep a session from 10 to 1. In case if you are not available at that point of time, let your IntelliPad admin know. I will repeat this everything on in Tuesdays and Thursdays call as well. And if all of you are available, we can take 3 hours of 2 sessions on 17th and 18th of August, and we will wrap up a lot of our topics. With that, let's call it a day for today, and we can connect back on Tuesday. I hope you enjoyed today's session. We completed inheritance, one of the pillars. In the next session, we'll wrap up 2 more pillars. Thank you, everyone. Have a good night.